This podcast is brought to you by LMU Munich.
Hello everyone, my name is Elisa and this is Jordi. He'll talk about getting started with Sharknado with Sharknado. So please welcome.
Well, hello everyone. Thanks for coming to my presentation. I know there are plenty of very interesting presentations during this one, so thanks a lot for being here. Today I'm going to talk about Tornado. Tornado is an asynchronous framework, and we're going to see the first steps in creating an asynchronous application using it. Okay? So a bit about me. I'm a software engineer at Skyscanner. Some of you might know it. It's a flight and hotel search engine. We also do car hire. And I've been doing Python for the last 8 years or something like that. Before that, I used to be a sysadmin and used to manage a lot of backend systems. If you want to follow me, I will be enjoying the show. If you have any questions or any feedback, please send it there. I will be very happy to have it and to answer any questions you may have. So what are we want to talk about today? Today we're going to talk about the main difference between synchronous and asynchronous applications and what does that mean when you're creating one. We're going to talk about the Tornado IO loop, some code examples, how to test your applications, some tips on running on production, and finally conclusions about everything. So how do sync servers usually work? Basically what we will have is that we will have one request per worker. And from the moment the request enters your worker, it will be running in there until it finishes. So in order to be able to respond to, let's say, 100 requests, you will need 100 workers if you want to respond to all of these requests at the same time. In this case, we will have a one CPU system, and we will have 2 requests. And as we can see, we will be switching context every time we're doing some syscall. So basically, we would start here, we would go to the second request, we would go all the way here. Here, the kernel would decide to steal the CPU from us, so we would switch to another worker. Then we will keep working. In the first request, we would go back, and finally, we would have some CPU idle time in there. What does this mean? That we don't really have any control on when we switch, and that we're at the complete mercy of the system. And that's a good thing in some cases. On the opposite side, we have asynchronous servers. On asynchronous servers, we basically have one worker per CPU, usually. And what we do is basically we run app logic all the time. And we switch in these places here using our application logic. So this means that basically our limitation stops being the system, but the time that we're running application logic for our application. So what's the IO loop? The IO loop is a reactor or an event loop. And basically what it does is it takes your applications, your application code, and every time there is an asynchronous request, it piles it up and waits for the results to come. So it will be storing all the requests that are waiting for asynchronous results or for an available CPU execution slot. So if we go back to the previous slide, the IO loop will be running in these red circles here. So every time one of our requests does an asynchronous call, we would go to the IO loop. The IO loop would decide who's the next one in line and would start immediately running that code. The nice thing about this is that we don't really need to switch context many times, because if the change is local, we can switch applications faster than we would if it was another process. How does it work? Internally, it uses epoll, pq, or select, depending on what's available. And there are multiple implementations. Tornado has a default, but you can use async.io in your Pythons, and you can put UV loop on top of that if you want to gain some speed. So let's see how a hello world looks like. Let's start by the bottom. We have this part of code here. So basically what we do is we define an application. We define a regular expression. With the regular expression, we say the routes that we want this application to go. And we define a class that will be the one responding to this application. So basically, every time we go to root, we will have this get method called. If we were to get a post request, we would have to define a function called post. If we needed to handle the lead request, we would put a method called lead. But for simplicity, all the examples will be using get. In this case, what we would see is basically a hello world. So let's see how that looks like. So if we go here, yeah, very similar to other normal frameworks you might be used to. So this code is completely sync. It works in Tornado, and there's not much difficulty here. So let's move to something that starts using Tornado-specific functionality. In this case, what we're doing is naming a regular expression name and then passing that as a parameter to our get function. In this case, what will happen is that if we go to hello/something, we'll see hello something in our application. Again, this is a very simple example, and we can test it here. And hello, Munich. This is still a sync example. So let's move to something asynchronous. Very simple again. In this case, what we're doing is just waiting for n seconds where n is 10, or a parameter that our client has sent. So how do we do that? We have this Tornado method that's get argument that will give us the value from an argument called seconds. The default will be 10, and what we will do here is call await sleep for the time that this happens. This method here will actually trigger the IO loop, so we would be context switching, so we're not blocking the rest of the requests happening in this CPU. If we were to do this in a Flask application, we would be blocking that worker for 1 second. In Tornado, this is basically instantaneous. The other thing that we need to notice is that we need to put an async here before the def get. Otherwise, Tornado wouldn't know that this function is actually asynchronous. So if we click here, we can see how it sleeps for 2 seconds. And we could call these a few thousand times per second, and nothing would happen with one single CPU. Okay, going back. So let's see what Sharknado has to do with this presentation. So some of you may know Sharknado. It's a very good bad movie. And what I decided to do as an example is to get quotes from the movie, from IMDb. So what this example does is it goes to IMDb, it gets all the quotes, it parses them using beautiful sub, and then it prints them back. We have 4 movies so far. The 5th one is coming in August, but we don't get quotes yet. So let's see how we do that. Can you guys see that, or is it too small? It's too small, okay. Let me see how we can, I don't know if we can zoom this. Well, okay. Can you guys read that? Is that better? Good. Okay. So at the top we have the imports, nothing important. Here we have a dictionary with the URLs, nothing important. At the bottom we have the initialization of the application, is like all the others you've seen before. And here what we have is the get. The get basically gets a quote that calls await on a getQuote function, and then it writes the result. So how do we actually run the getQuote part of the code? So we will try to get a Sharknado movie. We do that using an asynchronous HTTP client. That's very important. If we were to use requests in here, like we would do for Flask or Django, what would happen is that this would be blocking. So we would be blocking the worker for the whole lifetime of this call. If going to IMDb takes 200 milliseconds, we would be blocking all the requests that go to this worker for 200 milliseconds, and we don't want that at all. So we need to create an asynchronous HTTP client. For clarity, it's declared in every single call in here. Usually you would put this inside the application and reuse it as a singleton. And then we extract the quotes, but that's normal Python, nothing related to Tornado. So let's see how this looks like. Yeah. So basically, as you can see, we get quotes. We can change the movie. You should see those movies. Really bad. Okay, so how does it look, a main file for one Tornado application? Basically, oh, sorry. Let me close that. Yeah, now. I'm sorry if it's too small, but I'll try to explain it. So here we will have a run method that will get one regex per each class that we have. In this case, we have the root that points to hello world handler. We will have the quotes that point to the Sharknado quote class. We'll have a sleep that points to the sleep class. And then we'll have the hello, that's the one that we saw with hello Munich. And then we just create the HTTP server, we bind it to the port that we want, and we start. And with that, we're ready to go. So Tornado offers a lot of testing utils. These testing utils are very useful to be able to know that our code is doing what we expect to. The first one is a sync test case. This will generate an IO loop for us, so we can test asynchronous classes that we have in our code. We have a sync HTTPS test case that will create a Tornado server, fuel a future in a random port, and it will let us query routes directly from our tests, making it very easy to make end-to-end tests for our whole application. And then we have gentes that lets us create synchronous functions as tests. So if we want, for example, to issue a database call, sleep for 3 seconds and then get the result, we can do that from the test itself. Okay, here we can see how we would set up the test environment. Basically, we would need to define what IO loop do we want to use. In this case, it's the async IO1, because it's easier for certain tests. Then we will need to define the application that we want to use. In this case, we just want to test the timer handler. And we need to inherit from a sync HTTP test case. And then we can start writing the tests. In this case, we're doing an end-to-end test for timer seconds equals 1. And then we can assert directly with the response, checking that the response code is 200 and checking that the response it has actually slept for 1 second. So it's just really, really simple. You need to consider that by default, Tornado just waits for 5 seconds for the whole test to pass. So if you need to test something that takes more than 5 seconds, you need to change an environment variable. Otherwise, you will get an assertion, error, and it's going to fail. In this case, if you remember, the default was 10 seconds. 10 seconds are more than 5 seconds, so if we run this, we will get this exception. So you need to be careful with that. Now it comes the most tricky part of writing asynchronous code. That's actually being able to mock your futures and be able to test everything once it reaches that await call. So how do we do that? We have two ways. The first one is wrapping your mocks in futures. And that's very useful, especially if you don't want to depend on third-party libraries, but it's very, very hard to get it right at the first try. So in this example here, we would create a future, we would set the result to known, and then we would mock the future. And then, here you can see how we're mocking this and passing it as a parameter. So what this will do is actually wrap our mock into a future. So when the await arrives to that instruction, it will get a future inside. And then it can unwrap it, and it will get the known result that we set in our mock. Fortunately, there's a simpler path to do that. That's using a library called async patch that you can see here. See this line here? Async test mod, import patch as a sync path. Here we're using async patch, sorry. And what it will do is it will handle all the wrapping of the future directly for ourselves. So we don't really need to worry about this anymore, and we can treat it as a normal mock. And this simplifies very much our operation because we don't need to create 3 lines of code for every mock we want to do. So in this case, we simply need to patch the function using the decorator, and then we can directly do that. And it will work out of the box. We don't need to worry more. This is a completely unrelated test, but I wanted to show how gentes works. So if you want to add an await sleep, for example, in one of your codes, you just need to add this decorator here. And then you can write tests that actually does asynchronous waits. So I guess that you are guys interested in running this in production because you wouldn't be here otherwise. So what do we want to do? We want to measure everything. When you're running in asynchronous applications, sometimes it's hard to keep track of what's going on. So we want to have metrics for every single call, and we want to have metrics for every external dependency that we have. How can we do this easily? One of the simplest ways to do this is actually inheriting from request handler, that's the base class from Tornado, and adding metrics on top of that. So then we can make that all our request handlers actually inherit from this class that we just created instead of the Tornado default one. Then we just need to plug here on finish a code that actually sends metrics to our metrics system, be that statsd, OpenTSDB, or whatever you guys use. It's really simple and it's really fast. Second thing that you need to consider is that you want to add timeouts everywhere. There are a lot of libraries that don't really have sane default timeouts and can block your application for a long while. There are applications that don't really have the timeouts at all. So you can have a socket that for some reason is left there and you won't ever notice because you don't timeout ever. And other requests keep working anyway. So this request will never have a result and you may not notice that. This that you can see here is a sync HTTP client. That's the default HTTP client for Tornado. And as you can see, it has a 20-second timeout. But other libraries are not as diligent in defining sane defaults. So be careful with that. You need to consider that having blocks of sync code means that all the requests that come after that one will be blocked for this time, increasing latency incredibly. So please use only async-ready libraries to do I/O, because the time that it takes to do an asynchronous call is the time that you can be running a few million or trillion operations in CPU time. One single request can block a whole worker by itself, and it will be like the lemon situation where you have just one guy and 1,000 waiting for it to explode. And finishing, you will want to run one Tornado process per CPU that you have in your system. In this way, if you have an 8 CPU system, you will have 8 workers that can multiplex the requests that you have. This can easily get to a few thousand requests per second on a single machine without any problems, even if you have to go to multiple dependencies per request. So, wrapping up, Tornado is great if you have a lot of external dependencies or a lot of I/O or a lot of slow database connections. Basically, if you need to go outside and it will take a long while, Tornado is a great fit. And in general, any async framework will be. On the other side, Tornado is bad for static content. If you want to serve a static content, please use Nginx or something like that. And obviously, CPU-intensive work. You don't want to get caught with one request doing 3 times of CPU-only execution, because otherwise, your next request will have been waiting for 3 seconds, and that's not cool. The good things about running with asynchronous servers is that you don't need to spawn 2,000 threads to be able to respond to 1,000 concurrent requests per second. This means that usually we will get higher throughput and lower memory footprint. On the other side, a single request will probably be slightly slower in terms of latency due to all the overhead of having the I/O loop running. And chasing bottlenecks is way harder with asynchronous applications due to the nature of the asynchronous context that we have. So we will be switching between many requests in one worker, and it's difficult to track. So that's all that I have for today. All feedback is welcome. You will have all the examples from this presentation in this GitHub repository. If you have any questions, please ping me at Jordi Show or send me an email or talk to me later. I will be having beers.
We have 3 minutes left, so any question now, maybe? Anyone? Okay.
I have one.
Yes.
Yeah, sure.
Is it actually a web server, or is it just a framework?
It's a web server, but at the same time, it's a framework for socket communication. So you don't really need to do web applications. You could actually create an SSH server if you wanted. All the socket patching and everything just works, but most people really use it for HTTP applications.
So if you deploy Tornado, it's its own web server, so you don't need Nginx and Qt in front of it?
You can put it if you want. Actually, when I usually do it to add layers of caching and, for example, load balancing. Or you can have, for example, one Nginx that actually routes to 3 or 4 machines that actually have Tornado servers running.
But you would not need something like Unicore?
No, you don't need it. You could use it, but I wouldn't recommend it. No need. Yeah, sure.
Do you find ever that the time taken to do the monitoring and the logging actually outweighs the time to do the work for a task? And is that ever a problem?
No, not really. At least I haven't found this case. But I guess that if your library that sends logs or sends metrics is synchronous, you would possibly get in that case. But in my experience using asynchronous statsd clients that basically send UDP packages to localhost to another container, that's not an issue.
Okay, I guess there is no time left, so if you have questions, just come to Jordi. And in 5 minutes, we will have here a talk with scientific Python tools for non-scientific use. So, break.
Thank you, guys.